This podcast is supported by Siemens, your partner for industrial-grade AI.
Hi there, welcome to a new episode of the Industrial AI Podcast. My name is Peter Seeberg, and my guest today is Lukas Höhndorf. He is the Program Manager, Artificial Intelligence Aviation at IABG. Lukas and I are going to talk about safeguarding AI. Hello, Lukas.
Good morning, Peter. Thank you very much for the invitation. It's an honor to be here.
You're welcome. Looking forward to. Please introduce yourself to our listeners. Let us know what you do at IABG.
My name is Lukas Höhndorf. I work for IABG now for around 3 years. First as a data scientist and quite recently as a program manager for artificial intelligence and safe AI systems. So the topic started quite small 3 years ago and it got bigger and bigger as we know also AI is a rising topic and this also comes down to us at IABG. So I think it makes sense if I introduce the company first a bit.
Yes, please do so. Before we dive into safeguarding AI. Yes, I mean, I know a little bit. You happen to be, but that's just by coincidence, not too far away from where I'm based. But please tell our listeners, who is IABG?
Yes, so IABG stands for Industrieanlagen-Betriebsgesellschaft. We are a test and analysis as well as a technical consultant company with a headquarter in Ottobrunn in the south of Munich. We have around 1,100 employees and our main fields are offering testing and analysis services in automotive, in aviation. So I think for most of the Airbus aircraft, we have conducted structural testing. We have a very big space testing center at IABG. So also there, I think most, if not all of the European satellites and equipment that's sent to space is somehow going through our test facilities. We have a field called Infocom that's also including cybersecurity aspects. And we also are active in the defense industry. I personally come from subdivision of IABG, which is called the Innovation Center. So the idea is that with the modern topics that are upcoming, such as artificial intelligence as an example, it's like we investigate how these modern topics can be used for the, let's say, main divisions of IABG. So the Innovation Center was founded around 10 years ago. And also the Innovation Center got bigger and bigger. And our aim is to support the main divisions or the other divisions of IABG that are offering their services. And we try to think how these new methods and new ideas, essentially from research, but not just from research, can be used for the future portfolio of IABG.
Very good. And that's what we're going to be that's what we're going to be talking about, at least one specific topic, safe AI, just to bring that together. So in the future, if people see wherever they are in the world, if they recognize above there a plane, which would be like an Airbus, there would be a very high chance that the parts, let's say the wing of an Airbus in the past has been somehow tested in your facilities, right?
Yes, of course, not for every individual aircraft, but the model, of course. So when you start developing the aircraft, so at the beginning you have to conduct proper testing. And one of the famous things that IABG, as I said, has done is, for example, the structural test of the A380, around 15 years ago, something like this.
Okay, so let's then move into Safe AI. Tell us about Safe AI and your team at IABG.
When we talk about Safe AI, so one thing maybe to mention first, that's a very big topic. And we usually differentiate the things in three main pillars. So the first pillar we call the methods and tools. So of course, when you, let's say, have the vision like we at IABG have, that in the future we would like to offer certification and testing services of AI systems, as well as offer consultancy regarding AI in the future, you need to know about the methods and tools that are available that you can use to conduct these kind of testing. So that's the first main pillar. I guess throughout the next minutes, we will go into a bit more details of each of the pillars, but just to give you a rough overview for now. So that's the first pillar. Second pillar we call operationalization. So here we talk about IT systems, for example. So let's assume we have a customer, they have some kind of AI developing platform, framework, pipeline. How can we, with, let's say, in case we have a Safe AI module, how can we efficiently, let's say, test their algorithms from an IT perspective? How do the interfaces look like? Do we make the testing at our premises? Do we integrate something at the customer? Those kind of aspects are considered there. Also, we run several projects as part of the second main pillar that we call operationalization. And the third main pillar is standardization. So here the idea is that whatever we can offer in the future, or whatever the law situation or the standards are out there, this heavily depends our portfolio. So we investigate current AI standardization projects on the different levels. So be it on the international level, on the ISO IEC level, or in Europe, I'm sure we will talk about this today as well. We have the AI Act that then also is connected to the activities at Senelec JTC 21. And we have the German national level at DIN and DKE, where there are committees that essentially mirror the international activities and the European activities, and then in some cases develop a German delegation opinion and position for those activities. So these were the more general activities, and for us as a company, but of course also for me personally, also interesting is the aviation field, where there are also activities ongoing in standardization.
Okay, we'll move into exactly that topic just in a moment. I read somewhere that you said you're currently focusing on computer vision applications. Is that still accurate?
As part of Safe AI, yes, that's accurate. So when we started Safe AI, it was simply the most tangible topic for us. So considering also the background of IABG and its connection mainly to aviation and to automotive, we directly see some good application areas that fit to the company, but we also have, let's say, that also fit our personal backgrounds. So that's where we started. However, for Safe AI, we are dealing with computer vision mainly at the moment. This will probably also change next year, but also other teams of our innovation center are already dealing with other aspects such as NLP. We have a very strong NLP team. People deal with reinforcement learning. So this current focus on computer vision holds for what we call Safe AI in IABG.
The reason I was asking is, and I'm going to share with you a quote that I heard in a different podcast with Andrej Karpathy. You may know him, or listeners may know him. He's the former director of AI at Tesla, a podcast with Lex Friedman. And he specifically says, quote unquote, pixels are a beautiful sensor, cameras are very cheap, and they provide a ton of bits. Vision is probably the highest bandwidth sensor. It's the sensor that humans use, and therefore everything is designed for that sensor, quote unquote. Now, you already said, sure, you're going to be doing other things, but in how far would you agree with Andrej? It's not just per accident that you started with computer vision, I guess.
It's a very good question. And let's say the underlying situation is also that Tesla is, let's say, solely using computer vision and cameras for their perception system, right? And I think also it's a big discussion whether they should also use something like LiDAR sensors that's often used for other car companies. So they have quite strong opinion. And as you said, Andrej represented the company for a very long time and is one of the, as you said, former directors, so one of the main AI people there. So it's an interesting question. So we also had, it was essentially a research or a conference paper where we also tried to think what we did in Safe AI so far, mainly in the aviation side, how to put this into automation. And I guess we might also talk about this later on. We
will, yeah.
One thing that we did is data fusion. And we had, in my opinion, a quite nice idea there, how to use AI computer vision and especially a characterization of its uncertainty in a popular data fusion algorithm. So we thought about how this could be applied in automotive. So we didn't dug into many details there, but I still believe that at least it can be beneficial to have additional sensors such as cameras. So everyone, as you are well aware, and probably most of our listeners, whenever there is a Tesla accident, then this goes through the media and all the details of the accidents are then discussed. I remember, I think the first one was somewhere in California where the car then oversaw this white truck and unfortunately crashed into it, and then the driver died. Then the question raises, if you had a LiDAR sensor, probably somehow this truck could have been seen. So, I mean, the future will show what will be the correct thing. I can imagine that there will be some car manufacturers that will also use additional sensors to cameras.
And bottom line, humans do not only use our eyes. We also have ears, we have a nose, and we have a couple of other sensors, right? So, but then let's see if maybe the answer actually, and I would almost assume, lies in, compliance. So you make sure that AI regulations are taken into account. So you already mentioned, what role does then the European AI Act play? And maybe you can even give us a quick update on where we're standing. I believe, we're almost at the finish there. And second question, you already gave a preliminary answer. Do other regulations then exist on a global, on a European, on a German level?
So the European AI Act, I think in its first version was published last year, so in 2021 in April. And then, I mean, I'm not an expert on European lawmaking, but there's a rather long process now that it's going through. I think quite soon after it was published, I read through the AI Act, and there's a lot of relevant information, obviously. And however, it's a legal document in my perspective. So after the first draft, it went through several revisions. And in Germany, we have a very active Bitkom Arbeitskreis, it's called, on AI that's quite closely following the activities there too. So to everyone who is interested in the most recent updates, I guess this Bitkom Arbeitskreis is a good place to be active. And the information that I have is that, I mean, there are the different, I don't know the English term, but Ratspräsidentschaft, which is regularly changing from country to country. So they are pushing hard now for bringing it to a final version. And as far as I know, there is still some uncertainty when the law will be active, but it's probably sometime around the year 2025. More interesting for us as technicians, in my opinion, is not this AI Act, which is, in my opinion, a legal document, but it's the standardization requests that are, let's say, handed over to Sensenelec JTC 21. That's an AI committee on the European level that essentially said, dear JTC 21, please develop standards regarding these 10 topics. I think it was 10. And this is now the big job of this committee, to develop this standard, ideally, or let's say necessarily, until the law then gets effective approximately in the year 2025. And I mean, these standards are then really technical standards, so they give more technical details than the AI Act does. And there is now a big discussion in this committee, let's say, which standards to start from scratch, and for which standards we can refer to projects from the ISO IEC level, for example.
Okay, moving into a number of steps of more detail, talking about robustness, which is one of the requirements of the European AI Act. You have developed, I think, what you believe, a safe AI toolbox. Can you tell us what that is about?
Yes. So in terms of robustness, I mean, what's typically done, and what we also do, is that you have in our case, a computer vision algorithms that is supposed to detect some objects in an image or in a video stream. So our main example that we had over the last years is that we consider a drone vertically landing on a landing pad, and we then have an AI computer vision algorithm on board that is detecting the landing pad, and is essentially giving this information plus deriving the uncertainty about this information, where the landing pad is exactly, and then passing this information on to the flight control algorithm, and then certain things happen. So what we did in terms of robustness is that what happens now if you have a certain image, what happens if you augment this image or if you disturb this image, and there are a couple of tools available that you can, I mean, first of all, the very basic image characteristics, such as you can turn it a bit or you can crop it, can enlarge or shrink it, rotate it, and see how the AI performs. So these are probably the most basic things that you can do. Or you can use some filter techniques to change the image. There are toolboxes that you give an effect of snow or fog into the image. So that's one thing that you can do, that you essentially have an image and use those augmentation methods and then see, okay, how does the algorithm perform and how is the uncertainty characteristics based on the original image compared to the augmented image.
Yeah, that's a very nice example. I was actually personally part not too long ago of what is it? Is it a restart? The plane is just above. You're scheduled to touch down in the next 5 seconds, and then suddenly it restarts again, which is a very frightening thing if you haven't experienced it. And that was because of fog. So now you give the example of fog. So that was a very small airport. I believe these days there are systems which will bring the airplane down kind of automatically by systems. But in this case, let's compare this situation. I assume that in that case, the captain or who was the person flying the plane was making a decision. I do not see enough. I, human, do not see enough. It's too dangerous. It's a risk. So that's, as you said, compare that to the algorithm. That's the kind of tests that you would do, and you would be looking at the certainty of the artificial intelligence application at that time when you simulate fog on the image.
Correct. You can say this refers to the real case. I mean, there can be several reasons, of course, why the pilots then abort the landing. It can be due to visibility, that you don't properly see the runway. It can be through a runway incursion, that maybe other aircraft are still on the runway or enter the runway. So it can have obviously various reasons. But yeah, something similar we can also do with this fog example. And what you also then, have in a real world system, especially in aviation where safety is such a central aspect, is that you have very mature requirements, like what is the system that you want to build, which requirements does it need to fulfill. And yeah, based on these requirements then you have on the system, you can essentially derive the tests that you want to make. And in aviation, sticking with this example, so you have very clear examples or requirements at which visibility conditions, let's say, which kind of systems of the aircraft need to be active. Of course, if you have modern aircraft, it's also technically possible that you can lie in zero visibility conditions, but then certain systems need to be active and used, such as an auto-land system or head-up guidance system. So it's a question then how your system is built up. And for aircraft and aviation systems, this typically gets very complicated due to safety is so central.
Right. We may nevertheless stay with aviation. That's perfectly okay. But just mention quickly, maybe there are other applications in other areas for which you provide safety AI solutions as well.
Yes. So we started going into automotive in, let's say, so far in an internal project. It's about then detection of passengers. That's, I think, one of the main challenge, or if you compare the aviation industry from automotive, and especially concerning these AI perception algorithms, is in aviation you are in a very controlled environment. In automotive you are driving on streets through cities. There is, next to you there is a pathway, there are potentially kids playing around and passengers very nearby you. So that's a huge challenge, I believe. And in this internal project we now also investigate how can algorithms that detect passengers that might be very near to your car, how these kind of algorithms can be tested and which kind of characteristics they need to fulfill. But this is, of course, also a very big topic. Probably you are aware, maybe you even had it in one of your podcasts. In Germany, there is this big KI-Absicherung project. It has been going on now for several years with a very big consortium, including the main automotive manufacturers. So I think it was also a big topic there, and there were several publications from that project.
Okay, let's move on into the DIN Spec 92005 called Artificial Intelligence Uncertainty Quantification in Machine Learning. Can you give us a quick introduction what that's all about, please?
Yes, I would like to go back here and to the three main pillars that we said. So the first one was the methods and tools that we investigated in IABG. And one of the points where we dig a bit deeper was how can uncertainties be quantified, uncertainties of machine learning algorithms, in our case, computer vision algorithms. And there we really investigated, okay, what's really the current state of research and how can we implement this and how can we use this? And the third pillar was standardization, and we saw that for most of the topics out there, such as robustness, such as explainability, such as ethics, and so on, there are standardization projects that are ongoing, mainly currently on the ISO IEC level for AI, so the JTC1 SC42, it's called, the Committee for AI on that level. There are various projects ongoing. However, we realized that for uncertainty quantification, which is in our case, especially for safety critical applications, a very central topic, we realized that there is no standardization project going. I mean, none specifically for that topic. And of course, the topic somehow is mentioned in other standards such as robustness, but I mean, not to a very big level of detail. And we found this out maybe around one year ago, and we then asked some people. I mean, we were active in the community also at Dean. We discussed this with some people, and they said, yeah, you're right. This topic there is not much activity going on. In fact, we learned that it was discussed at the beginning of SC42, so of the ISO IEC committee level. However, they said, let's focus for now on other topics. So people motivated us to start a standardization project. And Dean Spec is, let's say, a first step. So it's a national project, obviously. It's organized by Dean. And it's like a first step towards a full standard. So it's usually the application process is a bit easier, and you can find a consortium and you can essentially start working on it. And yeah, this is what we have been going through in the last months. And then finally the kickoff was around 2 weeks ago on November 18th. We had the kickoff, and yeah, it was really a good start, I would say. So we had a very active consortium. There were some people we knew from the activities of the last years, but there were also some, let's say, newcomers in standardization. Some people who, for example, made their PhD research for several years on this topic, or even a sub-topic, let's say, of certainty quantification in machine learning. So we really, I mean, it was the first Dean Spec kickoff I attended, but I mean, we really used the entire 3 hours and had really, for the majority, also a very good technical discussion. At the beginning, you start with some organizational aspects, of course, that are necessary, but the remaining of the time, we had really good technical discussions. And the next meeting for it is now December 18th, I believe. No, sorry, December 16th is the next meeting, and our job now is, being the initiator and the project leader, is that we consolidate the discussions from the kickoff meeting, develop the next version of the document that's then continue being developed in the next months and discussed, of course.
Let me bring in my infamous hypothesis that whenever we will be embedding machine learning, so probability-based systems into, whatever kind of automation, be it aviation, be it whatever, coffee machines or other automated systems. My hypothesis is that we're always going to need a rules-based loop around any kind of such a system where the rubber hits the road. So, if we're going to allow an autonomous system to say, up or down, left or right, whatever, that we're somehow going to need a rule-based system. And then maybe, that's now my assumption, looking at the outcome of your quantifying your uncertainty, and then letting, the proposal of the machine learning-based system through or not. Is that a thought that you can follow, support, or?
Yes, I fully agree with you. There is one standard that we have identified in approximately the second year of our Save AI project or program, that's bringing up a concept of it's called runtime assurance. Specifically, it's an ASTM standard for aviation. But I think it goes in a very similar direction to what you said, that essentially if you have, they call it in their standard a complex function, which, for example, can be an AI object detection system. They say one way to realize this is to build something like a safety monitor around this that's checking the outcomes of the complex function, such as an AI, and decides then, can this function output be used for the following steps? Or should there be, they call it then recovery function, that are maybe not as complex, but follow more traditional ways. So I think this is going in a very similar direction to what you said.
Sounds a bit like, yeah. Oh, very, very happy to hear that. I wasn't aware of that development. Yeah. So you already mentioned. So maybe you tell us a little bit more about how that's going to work. You're at the first steps. We don't want to know the details of, unless at the end you're very happy to share. Maybe there's other listeners that will be interested of joining if that is still the case. But how would you go about quantifying uncertainties? And interestingly, I did 2 studies myself in the Netherlands, and one of them I finished with the topic of, at that time, the quantification of quality. So I'm very, I forgot most of it, I guess, but I'm very much interested in, what is the thought, maybe it's too early for that, but the base thought on how you quantify uncertainty from machine learning.
So I think there are 2 ways to answer this question: on a technical basis and on a, let's say, organizational basis, how this Dienstag will proceed. So let's start with the technical level. At the beginning of our Safe AI initiative, we quite quickly got to a PhD thesis of in the meantime, professor from England called Jaren Gall, where he used the concept of dropout for deep learning systems to quantify uncertainty. So we at that time had the plan to use the object detection deep learning neural network to detect this landing pad, as I said before. And what is now dropout? Dropout is a, let's say, traditional regularization concept. So the idea is to avoid overfitting, you must not rely too much on single neurons. So there is this concept to, based on a probabilistic approach, deactivate some of the neurons and then, let's say, retrain the algorithm on an iterative level. So the idea is to deactivate, let's say, 5% of the neurons and iteratively do this. They're not always the same neurons are deactivated. So that's in a nutshell the main idea of dropout. And that person had then the idea to, if you have one deep learning model, for example, for computer vision tasks, that you use this dropout concept to derive, let's say, 10 or 20 slightly different versions of this model. And now the intuitive idea, that's in fact also the correct idea, but the nice thing is that's so intuitive, is what about if you have now one image that you push in all of these 10 or 20 slightly different models? Of course, you will get 10 or 20, let's say 10 to make it easier. You will get 10 different results, obviously, because you had 10 slightly different models. And now the question is how different these 10 outcomes are from each other gives you a feeling for how certain the model is about the prediction. So if the 10 outcomes are very different, then it's an indication for the uncertainty is high. While if they are very similar to each other, then you can assume a higher certainty, so a lower uncertainty.
Sounds like deviation, something like standard deviation, or is that?
Yes.
Too easy.
Yes,
okay.
At the end, yes.
Okay, sounds great.
So that's really, the nice intuitive idea we had at the beginning. Then we said, okay, let's use this. Also realize, this is, of course, there's a huge amount of mathematics behind this. So it's really just the intuitive idea, and the devil is always in the details, of course. But we like this idea, and we followed this and used it also then throughout our project.
Very good. And number 2 is organizationally, you said?
Correct. So the Dienstag, we will carry it out for around 10 months more. So we expect to finish probably mid or late summer next year. We will have approximately once a month, we will have video conferences to discuss the progress of the document. The idea is there are different ideas. So first of all, we would like to collect all the terms that are related to uncertainty quantification in machine learning. So that's a typical thing you have in standards, that all the relevant terms are introduced, or in the main cases referenced and taken from other standards. But the standards should be also self-explaining. So you collect all the terms. And in our case, it will be obviously there will be relevant terms from the AI field, and there will be relevant terms from uncertainty quantification and statistics. The second idea we have is that we collect methods that are available for doing these kind of quantifications and find a way to categorize them. So for example, you might have very powerful methods. However, they might require heavy hardware and a long computational time. So one way to categorize these kind of methods is what are your requirements regarding real-time applicability, or how much hardware you have available. And it's of course different if you run an algorithm maybe on a big supercomputer cluster compared to if you fly a drone where you maybe have a tiny edge device. So these are requirements that have an effect on which method you can use. So yeah, the idea here, as I said, to give an overview about the available methods and how to look at these methods, like how to categorize them and give some indication which methods can be used in which situation. Okay, a further point of the Dienstspec, and probably the main part of it, will be to formulate guidelines and potential requirements for running these kind of algorithms. So there are aspects like, first of all, think about which kind of uncertainties you would like to model with the algorithm, which kind of uncertainties are relevant for the applications, and which kind of steps that are typically need to be gone through, such as, of course, calibration of the uncertainty quantification algorithm based on ground truth. Okay, and the last part that we plan to bring in the Dienstspec is a collection of use cases where essentially all the consortium members that are active in this field can provide and describe the use cases.
Okay, sounds great. Now, let's return to your working environment at IABG. Can you share with us one or the other thing about your development environment? You know, you're using certain platforms. You talked already about edge and cloud as differences. You're using certain languages, certain libraries, things you can share with us?
So as I said at the beginning already of the conversation, I come from the division called Innovation Center, which is quite young. And we have one IT infrastructure team that's building the IT infrastructure that's used in our team. And also we now more and more give access to it to other IABG people. So we have a cluster running, we have GitLab, we have various tools that you need to develop IT projects. And more and more these tools, also like cooperative tools like Confluence and Jira, more and more we now move it out of the innovation center to also give people of the other divisions access to this.
Okay. How about your team? How many are you? What do each of them do? What are the typical roles? Maybe you're even looking for colleagues to join. And if so, what should they bring to the team? Also, as we talk about it, not sure you're still looking for other companies, persons to join your Dienstspec 92000?
Yes, so the Innovation Center itself, I would say for IABG, it was quite a success story. So within the last years, we got bigger and bigger. And now, in fact, we are part of a restructuring process. So there are always new people welcome. So if you look at the career page of the IABG, there are various open positions on all levels, be it as a working student, or as a recent graduate, or as an experienced person, everything related to IT, to data science, especially fitting to the engineering background of IABG. Cybersecurity is a big topic for IABG, for our team. So everyone is welcome to look at our career page and identify the role that's fitting for you. And of course, also outside of IABG, we have this Dienstspec consortium. It's open for new consortium members. So even though the kickoff already took place, if you're interested in this topic, feel free to contact me or to contact Dean directly. You should also find this Dean spec called Uncertainty Quantification in Machine Learning on the internet, and then feel free to reach out to us.
Very good. We'll provide your details just in a moment. Coming to a close. So from your perspective, where are we standing then as far as safe AI is concerned in Europe, in Germany, maybe relative to the rest of the world, United States, China, Asia, and how do you see that safe AI is going to change the world of, analysis, simulation, testing over the next, 5 or 10 years?
So people usually say that Europe, needs to keep track of the developments going on in USA and in China, and it's correct. So those countries are, of course, leading in this field and push a lot into the direction of developing or also testing of AI systems. However, Europe shouldn't make themselves smaller than we are. So a nice example that I had, I think one of the last Olympic Games, where you have then, at the end always these rankings about which country has how many medals. And at the end, there was one, after the tournament, there was one publication by European Commission who then summed up all of the European countries, and then they were by far leading this ranking of medals of the tournament. So Europe is in a good position. Of course, we can catch up with the developments of those main player countries, but we are in a good position. AI will be further be relevant, and I mean, if you look at how fast the developments are, and I mean, one of the things that started my intention for AI and how powerful is this discussion about AlphaGo in 2016, and all the developments are of DeepMind. So they are really pushing the boundaries of AI, in my opinion, of Tesla. So it's really a technology with a very big potential in the future. And of course, if you use it in safety critical systems, safe AI is something necessary. And we as Europe, especially in Germany, there is a big political push in this direction. So probably you heard about the De-Normungsroadmap, which will be now published very soon in its second edition, where, let's say, also political interest is there to let the companies develop in this direction. So we as Europe, and particularly we as Germany, we are in a good position. We can catch up with those leading countries and then have a very interesting and exciting future of AI, and in particular of safe AI systems.
Looking forward to Lukas. Thank you very much. Yes, we're only the European Union today, but we shouldn't be too modest. It's one of our values, actually, I believe, as in general, as Europeans, but we're not yet the United States of Europe. If that would ever be the case, then I think you're suggesting indirectly it would be easier to compare the United States of Europe with the United States of America and China, other countries. So as you say, looking forward to, and we can be modest, but we should also be aware of what it is that we are. And you were one very great example of that today, sharing with us what it is that you as a company, and together with many other companies, you're doing on the area of safe AI. So Lukas, thank you very much. Listeners that want to get in touch with you, specifically regarding maybe IABG, your work, or the work of the DINSPEC 92005, they can best contact you at LinkedIn. That's Lukas Höhndorf, Lukas, and then Höhndorf goes with HO with 2 dots on it, NDORF at AIBG. Otherwise, if you, dear listeners, have any questions, comments, you can always send me an email as well, Peter at aipod.de. Very happy that you stayed with us so far. Looking forward to have you with us again. Lukas, thank you again. See you soon. As I said, we're actually not too far away from each other, so I may just pop in for a cup of coffee sometimes. Thank you very much. Have a wonderful day.
Thank you very much, Peter. Bye-bye.
Thank you. Bye-bye.